points that we are going to discuss in this presentation. These are introduction, principle, instrumentation, interferences, and applications of FES. So first we start with the introduction. What is the introduction of flame emission spectroscopy? Flame emission spectroscopy is so named because of the use of a flame to provide the energy of excitation to atoms introduced into the flame. It means that when we introduced the atoms into the flame provides excitation energy to these atoms. So next is the principle of flame emission spectroscopy. The principle of flame photometer is based on the measurement of the emitted light intensity when a metal is introduced into the flame. The compounds of alkali and alkaline earth metals dissociate into atoms when introduced into the flame. Some of these atoms get further excited to higher levels, but these atoms are not stable at higher levels. Hence, these atoms emit radiation when they return back to their ground state. These radiations generally lie in the visible region of the spectrum. Each of the alkali and alkaline earth metals has a specific wavelength. So this is the diagram that shows the principle of flame emission spectroscopy. In this diagram, it shows that in flame emission spectroscopy, the given solution is converted into gaseous form through the process of aspiration, and this gaseous form is then dissociated into atomic form by the energy of flame. These atoms then absorb energy in ground state and excited to higher energy state. As we know that the excited state is very unstable state, so these excited atoms returned back to their ground state by emitting photons and create sharp line spectrum. So next is the instrumentation. So there are some basic components of flame photometers. These are burner, atomizer, monochromators, detector, and readout device. Now we will discuss all of them in detail. So first we start with the burners. The flame used in flame photometer should possess following functions. So there are some important functions of flame that is used in flame photometer. So the first one is the flame should have ability to evaporate the liquid droplets from the sample solution in the formation of solid residue. It means that the flame has ability to convert the constituent of liquid sample into the vapor state. The second one is the flame should decompose the compounds in the solid residue, resulting in the formation of atoms. It means that the flame also have the ability to decompose the constituents into atoms or simple molecules. So the third one is the flame must have the capacity to excite the atoms formed and cause them to emit radiant energy. It means that the flame also have the ability to electronically excite fraction of the resulting atomic or molecular species. So these are some flames that we use in flame emission spectroscopy. So there are some elements: potassium, lithium, calcium, sodium, barium, and their wavelength range that lies between 550 to 760 nanometer, and they absorb various colors that are violet, red, orange, yellow, and lime green. And next is the types of burners. So there are few types of burners: Maker burner, total consumption burner, laminar flow burner, Lunder graph burner, shielded burner, and nitrous oxide acetylene flame. So we will discuss all of them in detail. So first we start with the Maker burner. Maker burner. This burner employed natural gas and oxygen, produces relatively low temperature and low excitation energies. These are best used for alkali metals only. Nowadays it is not used. So when we talk about Maker burner, we can say that Maker burner was the primitive type of burner used in the flame photometry and was used earlier. It generally works with the aid of natural gas and oxygen as fuel and oxidant, and the temperature so produced in the flame was relatively low, and it results in low excitation energy. And nowadays it is not used, but it was best suited for alkali metals only. So next is the total consumption burner. In this burner, the fuel and oxidant are hydrogen and oxygen gas respectively. In this, the sample solution is aspirated through a capillary by the high pressure. Fuel and oxidant are burnt at the tip of the burner. When we talk about a total consumption burner, we can say that in total consumption burner, hydrogen and oxygen are generally employed as fuel and oxidant, and due to high pressure of fuel and oxidant, the sample solution is aspirated through capillary and burnt at the tip of the burner. And next, there are some advantages and disadvantages of total consumption burner. Design is simple and entire sample is consumed. And the disadvantage is that a uniform and homogeneous flame is not obtained, since droplet size vary, leading to the fluctuation in the flame intensity. Their advantage is that there is no waste of fuel, and disadvantage means that the flame we are receiving at the tip of the burner is not consistent, and its size vary according to the size of droplet, as we are receiving variable size of droplets due to its capillary action. So this is the diagram of laminar flow burner. Laminar flow burner. Laminar flow burner is also called premix burner. In this type of the burner, aspirated sample, fuel and oxidant are thoroughly mixed before reaching the burner opening and then entering the flame. Important feature of this is that only a small portion, about 5% of the sample, reaches the flame in the form of small droplets and is easily decomposed. So there are some advantages and disadvantages of premix burner. These are premix burner is non-turbulent, noiseless and stable. Easy decomposition, which leads to high atomization. It can handle solution up to several percent without clogging. And the demerits are when it contains two solvent, the more volume will evaporate and lesser will remain undissociated.
That are used in the flame emission spectroscopy. Firstly, I will explain what are basically monochromators and filters, their function. So monochromators are usually optical devices that separates polychromatic light into a range of an individual wavelength. Means a polychromatic conversion of a polychromatic light into a monochromatic light. This is the main function of monochromators. So the monochromators that should be used in the simple flame photometer, they are usually made up of prism, and quartz is the main material that is most commonly used for making prisms, because quartz is transparent over the entire region. Next, the filters are also used in the flame emission spectroscopy. What are the filters? Filters are basically porous devices for removing impurities or solid particles from a liquid or gas passed through it. So the composition of the filter is, they are made up of such type of material which is transparent over a narrow spectral range. So both monochromators and the filters are made up of that type of material that should be visible to the flame emission spectroscopy. How they are used, both monochromators and filters, in the flame emission spectroscopy? When a filter is kept between the flame detector, the radiation of the desired wavelength from the flame will be entering the detector and be measured. The remaining undesired wavelength will be absorbed by the filter and not measured, because the main function of the filter is to remove the undesired wavelength. In flame emission spectroscopy, the wavelength as well as the intensity of the radiation emitted by the element has to be monitored. Therefore, both the monochromators and the filters are used. Next, the detectors. Detectors. What are detectors? Detectors and their function. Basically, the detector and their function is to measure the intensity of radiation that are falling on the detectors. So three types of detectors are used in the flame emission spectroscopy, that are photovoltaic cell, phototubes, and photomultiplier tubes. Next, the interferences. Four types of interferences has been conferred in the flame emission spectroscopy. What is basically an interference or interferences? Interferences are usually considered as a disturbance by which we cannot get the characteristics wavelength or desired spectra of the test element. So by this definition, four types of interferences are considered. physical interferences, chemical interference, ionization interference, and the spectral interference. The first one is physical interference. Physical interference. How the physical interference occurred and what is the basic of physical interference? We say that when the most of the parameters that affect the rate of sample uptake in the burner and the atomization efficiency, these type of interference are generally considered as the physical interference. Atomization efficiency, nebulization efficiency, these are the same. It means when it is a process when the sample is broken into fine spray. When this process is affected, then usually the physical interference occur. When a sample is more viscous or has different surface tension than the standard sample, then it can also due to these type of parameters, differences in sample uptake occur, or due to which the nebulization efficiency is affected. Such type of interferences are basically minimized by matching as closely as possible the matrix composition of the sample with the standard. The next one is the chemical interference. Chemical interference is also termed as the refractory compound formation interference. These types of interference basically occur when the refractory elements may combine with the oxygen to form the thermally stable oxide. These types of oxides cannot be decomposed by the low temperature flames. So analysis of such elements can be carried out at high temperature flames such as the nitric oxide acetylene flame to dissociate these thermally stable oxide, because the air acetylene flame is a low temperature flame and it cannot provide the high dissociation energy to these thermally stable oxides. So the high temperature flame nitrous oxide acetylene flame is used for their decomposition. The next, the chemical interference also occur when the calcium reacts with the phosphate present in the solution and form the calcium pyrophosphate, due to which the reduction in the absorption of the test elements occur. To overcome this chemical interference, releasing agents like strontium chloride or lanthanum nitrate 1% are added to the solution that will preferably react with the phosphate and prevent its reaction with the calcium. So the calcium will be available in the atomic form to absorb the radiation, and hence we can test that element. The next, that chemical interference occur, that is the same when the calcium react with the phosphate or form the calcium pyrophosphate. To overcome this type of interference, if we add the EDTA solution that reacts with the calcium and EDTA form a calcium EDTA complex that is dissociated into the flame to give free calcium vapors, because the compound that formed previously, calcium pyrophosphate, that is a stable compound and cannot be dissociated easily. So when we add EDTA, the calcium reacts with the EDTA and form a calcium EDTA complex that is a weak complex and can be dissociated easily, and the chemical interference is avoided. The next one is ionization interference. Ionization interference is usually occurs when the alkali and alkaline earth metals and several other metals in a very hot flames may be ionized in the flame, due to which the selectivity and linearity of the process is also reduced and absorption signals can be decreased. So to avoid the ionization interference or to overcome the ionization interference, easily ionized elements like potassium, cesium are added in the sample solution. Easily ionized elements in the sample will add free electrons to the flame and suppress the ionization of the test element. Hence, the ionization interference can usually be overcome either by adding the same amount of the interfering element to the standard solution, or more simply by adding large amounts to both the samples and the standards to make the enhancements constant and ionization minimal. These are the two major processes that are used to overcome the ionization interference. The next one is the spectral interference. First, I will explain what is actually a spectral interference. Spectral interference is usually when either an other emission line or a molecular emission band is close to the emitted line of the test element and is not resolved from it by the monochromators. The spectral interference occurs. It is due to the light scattering or absorption by the solid particle, due to the unvaporized solvent droplets, and due to the impurities present, such as the oxides of other elements. The spectral interference is usually overcome or minimized by following ways, but it cannot be eliminated completely. By using the line source in the flame emission analysis, we can overcome the spectral interference, and by using the AC instrument instead of using the DC instrument, we can control the spectral interference. The next are the applications of the flame emission spectroscopy. And the first one is flame photometers are widely used in quality control where sample and quick determination of alkali and alkaline earth metal is required. Basically, the main usage of the flame emission spectroscopy is usually the determination of the alkali and alkaline earth metals. The next one is used in laboratory to determine the concentration of sodium and potassium in biological fluids like serum, urine, and in any other sample. We can determine these types of metals by using the flame emission spectroscopy. Next, used in the determination of calcium and magnesium in cement. Then used in the determination of lead in petrol. Flame emission spectroscopy also used to determine the metals present in chemicals, soils, cement, plant material, water, air pollutants, and oceanography. It has various uses. It can also be used for metal analysis, environmental samples such as air and water analysis, and in occupational health and safety areas, the flame emission spectroscopy can also be used.